Well, hello, calculus students and seekers of truth. In this video, we finally get to do some calculus with polar equations, polar coordinates. And the hardest, the more challenging part of this is not so much doing the algebraic work to finding the derivative. It's actually trying to understand what that means physically. So let's do the easier part first. And I wish to point out to you here that we have a lot of variables floating around here. We have r, we have theta, we have x, we have y. Okay, so we have 4 variables that we could be taking the derivative with respect to. There's maybe 12 different versions of the derivative that we could seriously talk about here. Okay, so let's start with an example here. Let r be equal to this equation in terms of theta. When theta equals pi over 6, calculate the following quantities. Okay, so dr d theta is the derivative of r with respect to theta, which is not hard at all. We can take this equation and just work it through as it is. So the derivative of 3 is 0, the derivative of sine is cosine, and this is negative 2 sine, so it becomes negative 2 cosine theta. We want the derivative dr d theta at theta equals pi over 6. So we just have to plug in pi over 6 for theta. So this is negative 2 times the cosine of pi over 6. Cosine of pi over 6, if you recall, is root 3 over 2 times negative 2. So that's just negative root 3, or about negative 1.73 something. Alright, we will deal with what this means in just a minute. Let's practice a little bit more, some of the algebraic work behind this. Dx d theta. So now we have to convert r and theta into terms of x and theta. Okay. So if you remember, how is x and theta related? Well, x is equal to r cosine of theta. Therefore, if we use this formula right here, x is equal to r, but r is just this part right here. So this is equal to 3 minus 2 sine theta times cosine of theta. So it gets a little bit messier. X is equal to r cosine of theta. R is equal to this equation. So now you make that substitution, and now you have this problem here that it's maybe a little bit messy, but I'm sure we can take the derivative of it pretty straightforwardly. Dx d theta, remember we got to use the product rule here, so that's the derivative of the first, which is, we already know, is just negative 2 cosine theta, times the second, which is cosine theta, plus the derivative of the second, the derivative of cosine is negative sine, times the first part, is 3 minus 2 sine theta. Okay. I am going to simplify, or you know what, let's not simplify it, let's just do the substitution first, and then we're going to simplify it. So now we want to know dx d theta when theta is equal to pi over 6. Right? That's still what the question is asking us. So we'll make our substitution here. Negative 2 times cosine of pi over 6, that we already know is negative root 3, times cosine of pi over 6 again, that is root 3 over 2, plus the negative sign of pi over 6, so sine of pi over 6 is 1/2, times 3 minus 2 times the sine of pi over 6, which is 1/2. Okay. So let's work all of this out. Root 3 times root 3 is just 3, so that gives us negative 3 over 2, plus this is 3 minus 1, so that's 2. 2 times negative half is negative 1. So negative 3 halves minus 1 is negative 4 halves, or negative 2. Okay. So the derivative of x with respect to theta when theta is equal to pi over 6 is equal to -2. All right, once again, we will go back to this and try to interpret the meaning of what these numbers are. Onwards, dy d theta. Okay, so dy d theta, well, again, not too challenging to solve for here. Dy d theta, remember that y is equal to r sine theta, and r is equal to this part, right, from the problem that we were given. So we can just make that substitution. We know that y is equal to 3 minus 2 sine theta times sine theta. And then this time I'm going to distribute, and I'm going to distribute first before I try to take the derivative. So this is 3 sine theta minus 2 sine squared theta. Okay. So dy d theta is equal to the derivative of 3 sine, which is just 3 cosine, minus 2. And this is sine squared. It's the chain rule that we got to use here. So it's sine of theta wrapped inside of x squared. So the derivative of that is times 2 sine of theta times the derivative of the inside function, which is sine. The inside function is sine. The derivative of that is cosine. Okay. So that's what that all looks like. Maybe we simplify this a little bit. This is 3 cosine theta minus 4 sine theta cosine theta. And then we want to know dy d theta when theta is equal to pi over 6. So 3 times cosine of pi over 6, 3 over 2, minus 4 sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. So all of this cleans up pretty nicely. We get 3/2 root 3 over 2 minus 2. No, minus just root 3 over 2. So we could factor out a root 3 over 2. And this leaves us with 3 minus 1. So that's just 2. Right? So this is root 3 over 2 times 2. So it's just root 3 over 2 again. Or about 1.73 if you prefer decimals. All right. So hopefully you get the idea, and I've saved, of course, one of the more difficult problems here to finish out this example. What about dy dx? Okay. How do I do that? Well, there's a couple ways we could approach this. We could set up some sort of equation. We could take x here and solve for r and then plug that into here so we get y in terms of x. But if you think about this a slightly different way, notice here that y is, we'll go with this equation here, y, we have y in terms of theta, and this equation here we have x in terms of theta. Okay, and I'll ask this question and pause a little bit, like, what does this remind you of? So it's an equation where you have x in terms of a variable and y in terms of the same variable. So you think about this, this is basically, it's like a parametric equation. The two that I put in stars, it's like a parametric equations, right? But instead of using t, we're just using theta this time. So if you remember, you can go back to those notes. This is the, I think, 10.1 notes. The parametric equations tell us that dy dx is equal to dy dt over dx dt. Except this time, we're not using t, we're using theta, that's all. So dy dx is equal to dy d theta over dx d theta. Okay? So even though this looks like it could have been really messy, thank goodness we already have done all of the difficult work, so we can just combine them together. Dy dx is equal to dy d theta at theta equals pi over 6, which we figured out is just root 3, divided by dx d theta, which we already figured out is just negative 2. So this is just negative root 3 over 2. Phew. Okay. So we've avoided a big mess here by understanding and being able to envision this as a problem that is very much like parametric equations and the two equations that I put in stars right here. Okay, so there is kind of a relation between polar and parametric. All right, so I'm going to end this video here, and in the next one we'll talk about what do these quantities actually mean. What you should do is maybe before you watch it, try to ponder and try to make sense of this a little bit before you watch it. Okay, thank you for watching and have a wonderful day.